Good morning and welcome to Let's Practice. We are talking about two first-degree equations with one variable. Let's start with an introduction. What is first degree? Well, first degree means that all of the variables we have, like this x and y, have the power of 1, not squared, not cubed, 1. That's all what it means. And what we can do with it, we can move things around, isolate the y, and then we're going to get something which is an identical to a straight line equation. Okay, as you remember, a straight line has a slope. Here the slope is minus 2/3 and has an intersection with the y-axis at y equal 1/3. All right, there is the slope, there is the intersection. So every time we're getting a first degree equation with two variables, we actually are looking at a line. Okay, so I want you to think of it as lines from now. So we have our two equations here, which are two lines. Okay, let's manipulate them a little bit, change things around, and isolate the y, and we'll see that we have two distinct lines. And we can draw them, and we see that one of them is the with slope of equal to, which is uprising slope, going upward, and then we have a negative slope right here that going down. The negative one is crossing the y-axis at y equal 1/3, and the positive slope one is intersecting the y-axis at y equal 11. What is important here that when we are asked to find a solution to a set of two first-degree equations with two variables, what they actually want us to do is to find this, the crossing between those two lines. This is the solution. Okay, so when they ask you for find me the solution for these two equations, they're actually asking for where are the line intersecting. So, all right, so we learned the theory. So what do we do? What do we do in practice to find the intersection between the two lines? So remember, our goal is to reach a single variable equation, meaning that we want the problem to be represented not as a two equation with two variables. We want it to have a one equation with one variable. So let's do that. Let's take our two equations. Let's do some rearrangement of the algebraic term to get y on the one side and everything else on the other side. And let's put them right above each other. Now we're going to use comparison, the first tool. Let's say we know that on the point of intersection, where our solution is, both lines have the same x and the same y, right? So we can say that the y are equal in this point. We can also say, because of that because y is equal, because of this sign, equal sign, we know that this y is equal to what on the right, and this y is equal to what is here on the right. So we can say that they are equal too. Let's use this equality to get us an equation with one variable. And we know how to solve that. We did it plenty of times. So let's do some rearrangement, some moving around, some dividing, and we're going to get that x is equal to -4. If these steps were too fast for you, feel free to pause the video and do it yourself with me. Or you can watch our previous playlist on first degree equation with one variable. So now we have the x of the intersection point, but the point, okay, on the on the system of axes, x and y, we need another coordinate. We need a y coordinate, right? So let's use this equation right here. We're just going to take one of the lines. It doesn't matter which one. And let's plug this x into here. And then we're going to get a y. Let's do some algebra, and then we see that y is equal to 3. So we solved it. We find the point of intersection between these two lines, and we did it by using the tool of comparison. Now let's go back to a little bit of theory, okay? And we need to know something about those lines. Because these are first degree equations, these are straight lines, right? We already established that. But we have three possibilities with straight lines, right? We have the first possibility that the two lines are the same, right? And in that case, which I try to represent here, every point on those lines are intersection points, meaning that if the lines are identical, we have infinite solutions. That kind of scenario doesn't interest us very much, right? We're not going to meet it. It doesn't give information. It's not very useful except for very deep mathematical theory. So let's not use that at all. We're not going to meet any exercise that involve this scenario. And we have another option. Our two lines are not identical, but they have the same slope, meaning that those lines are parallel. And as you know from geometry, two parallel lines will never meet, meaning that they're not going to have any solutions. This case, which we can theoretically have this case, and I already saw an exercise where this was the case, and it was quite confusing to me as a kid. It's possible. If you see that you are isolating the y and you get a straight line equation which have the same slope, meaning they will never meet. Don't accept to have a solution. But mostly we're going to have scenario C. In this scenario, we have two lines, and the two lines doesn't have the same slopes, which is great because when two lines doesn't have the same slope, they're not parallel, they're gonna meet. We are gonna have a solution. So thank you very much. This was the introduction for the subject of two first degree equations with two variables. If you enjoyed it, give it a like, share it with your friends, your classmates, okay? Even to someone who already think he knows the subject, maybe he can learn something. And thank you. I will see you on the practices. We're going to have 1, 2, or 3 practices about the subject. Then we're going to have a summary and, yes, homework, as I promised. So I'm going to see you in the next one. Thank you very much.